I hope you're having a good Christmas break. When we come back on the 6th of January, we're going to start Unit 6, and we're going to be looking at parameter changes of square root functions. So before we jump into the parameters, let's take a look at the parent. The parent function is the square root of x. F of x equals the square root of x. So let's explore this parent quickly. So first of all, we're only going to be looking at the real numbers and not the imaginary part. So we are not going to input any negative numbers into the radical. So we're going to go ahead and start at 0. And we're just going to go ahead and look at the perfect squares to make this easy. So plugging 0 into x, we get the square root of 0, which is 0. Let's go ahead and plot that point right here and get a look at our parent graph. Plugging 1 in for x, the square root of 1 is going to be 1. So 1, 1. 4, the square root of 4 is 2. So 4, 2. And then finally 9, the square root of 9 is 3. Okay, so this is not a vertex. Remember when we were talking about quadratics and absolute value, we talked about the vertex. Well, we're just going to call this, either we could call this the starting point, or I might call it this special point. This is the point that we would translate when we do transformations. Anyway, so we're going to start here, and this is going to be what our square root function looks like. I highly recommend that you memorize this table just like you memorize the parent table for quadratic functions. Okay, so now we are going to look at some different square root functions that have been transformed through the use of what we call parameters. So let's take a look at those parameters. Now we've already learned these parameters during first semester, but I tried to write down some information to help you remember. So here we have a square root function, and it shows the different parameters. We have a, b, h, and k. All of them play a role in transforming function g. So a, remember, I'm going to use absolute value this time because if a is negative, sometimes students get confused whether a is greater than 1 or less than 0 or what. But looking at the absolute value of a, if it's greater than 1, we have a vertical stretch. And if a is between 0 and 1, we have a vertical compression, which most of you already know that, and it's up on the poster in the room. Secondly is b. Now b, remember, is your horizontal stretch or compression, and it's going to be the opposite rules as vertical stretch and compression. Now, one thing very important to remember with b is sometimes you have to factor it out. So if your x has a number in front of it other than 1, and there is an h value, you will need to factor it out of both terms. H translates h units horizontally. Remember, it's always the opposite. So if this was -2, that would be 2 units to the right. And if it was +2, it'd be 2 units to the left. Translated. K translates k units up or down. And then finally, if a is negative, it's reflected over the x-axis. If b is negative, it's reflected over the y-axis. So there was a quick 5-minute review of your different parameters. So what we're going to be doing when we come to class is we're going to be looking at an equation, writing down the changes, the parent function is going through based on these parameters. Okay, so let's look at an example. Okay, so let's say we have this problem. As you look at it, the very first thing you should do is factor out that b value to get a clearer or better understanding what h is, because h is not -9. Okay, so let's factor it out. So remember, factoring means to divide. There. Now we have an A, a B, a H, and a K. Now will you always have all of them? No. But I just want you to see that it's possible. Okay. So right off the bat, we have, because of the 2, we have a vertical stretch. I'm going to go ahead and abbreviate for time's sake. Okay, 3, we're going to have a horizontal compression. Remember, opposite rules. So if this is greater than 1, stretch. But if this is greater than 1, it's going to be a compression. Opposite rules. And here we have translation, 3 units left, and here we have 1 unit down. Now these parameters hold true to any function that we're going to learn about in the future. So let's go ahead and, now that we've written down the transformations, let's go ahead and graph it. So a good first place to start is with the parent table. And hopefully you will memorize these. 0, square root of 0, 0, 1, 1, 4, 2, 9, 3. All right. We're going to extend x out, and we're going to extend y out. Okay, so what affects y? Well, what affects y are the parameters on the outside of the grouping symbol. Here the grouping symbol is the square root symbol. So we're first going to multiply by 2 and then subtract 1. Now on this side, you know, here we did order of operations forward, okay? But over here, we're actually, normally you'd start off with your grouping symbol first and then multiply. But remember, inside the grouping symbol, it's the opposite. So we're going to actually start by multiplying by a third. Opposite. It's times 3. So we're actually going to multiply by the reciprocal, which is the same thing as dividing by 3. Don't forget, these are going to be opposite operations over here. So multiply by a third and subtract 3. Okay, let's see what we get. Now I've already done the math for us. And over here, multiplying, subtracting. Multiplying, subtracting. Multiplying, subtracting. Multiplying, subtracting. Let's do the same thing on the other side. Multiplying, subtracting. So our new coordinates are going to be This is going to be our new x, and this is going to be our new y. So, on our graph, let's start by plotting our parent, 0, 0. There's our parent. Okay. Now you may want to use a different color, but you don't have to. You should be able to look at that and say, yep, that's the parent. Let's plot the new one. New one. Let's see, -3, -1. Notice our translating point. The point that we translate is our starting point, or a special point. And it went 3 units left, 3 units left, and 1 unit down. So that new point went 1, 2, 3, 1. Okay, next point, let's see. I'm going to pause the video just for a moment. Okay, I'm back. I just wanted to get an Inspire calculator so I could show you what this looks like. So I plotted the remaining x and y coordinates, and so we get this. You connect those points, make a little curve to it. Okay, and just to show you that it works out, I have it here on the Inspire calculator. Here's your parent function, and then here is the new transformed function. So in class, again, you will be writing down how the parent is affected by the parameters, and then you will be graphing a transformed function using a transform table in order to make a transform graph. Hey, if you get a chance over the break, try to pick yourself up some graph paper, notebook. That'd be great. I do have graph paper in class for you to use, but it comes in handy. Hope you all had a great Christmas, and I'll see you on the 6th of January, ready to go.